Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, so I'll switch to English now for the rest of the presentation. And so the talk is about semantic computing for eScience. I will start giving a little bit of my background, what I've done in academia, and then in industry. I've been at Microsoft for over 11 years. And then the two topics I'll be talking about today. One is data to drive innovation, and what type of next generation innovation we're looking for. And I will be focusing specifically on doing data-driven research and what it means when we engage with academic research to have access to data, and how can we as industries work with academia to see how people can actually do data-driven research large scale. The second topic I would be focusing on is like when we move on the paradigm from data to information and knowledge, so going towards this knowledge world. So what does it mean now in terms of access to what? Is it data, but what type of data? And here I will be talking about the type of knowledge that we could make access to the research community. So first of all, a little bit of background. I've been, so I did my studies in France, my doctorate there. My area of expertise is in computational semantics, and I've worked on natural language generation too. A lot of lexical semantics, as you can see in some of the publications there. And then I moved to industry about 11 years ago. First, I went to a business unit, and that was very interesting to see how to apply all my academic training to actually developing some products. And I worked in the area of actually the system help for Windows, and I worked in the areas of semantic search and to mostly natural language processing. I've been in Microsoft Research now for about 6 years, and I'm driving the Semantic Computing initiative, which is about how can we go from data to information, knowledge, and intelligence in terms of our interactions with academia, and what does it mean? What type of programs do we need to build so that we can advance the science there? So here's the overall vision. It's about enabling the next generation internet by working with you in academia, by working also with stakeholders in industry, by also working with government agencies. So for instance, the programs I'm driving, in the US, I work with the National Science Foundation. And last but not least, also engaging very closely with internet consumers, innovators. And this is to enable this paradigm, right? Data, information, knowledge, intelligence. So first of all, data has become a first-class citizen. And I think for this audience, I think this is not very debatable. I think that you would acknowledge that, yes, we need data. A lot of the research that people do here, and specifically in the context of the sciences, you need to have lots of data. So it's really a data-driven world. And when we look at how it has influenced the way we do research, here are some applications where data-driven have really changed the way we address the way we deal with spell checking, with machine translations, and so forth and so on. So for instance, for spell checking, it's not so much about crafting rules. So spell checking is about, you know, when you, for instance, in the context of search, of web search, if you enter a query in the search box and there are some misspelling, so the search engine is going to suggest some other spelling to see whether or not that's what you're looking for, so that then it can better match against some documents. So, and today, the more you have data, the better. So it's really this data-driven world. Same thing for machine translation. Actually, machine translation, I know there are some talks later in the day or tomorrow which will go in more detail on that. But this one is interesting to me because I did work on machine translation pre-web, so when there was not so much data out there. And not only that, but I also worked using an ontology-based approach, so very different approach, so that you will be hearing later today. And my learning when I did machine translation at the time is that that approach, where we were designing some very crafted ontologies to translate between natural languages, it was difficult to scale that when we changed from domain to domain, and extremely expensive. And in this new data-driven world, it becomes cheaper to do. So basically, here's also some citations from Banco and Brill, some of our researchers at Microsoft, who in 2001 said, it's really about the data size. Of course, it's not just that, right? The world is not black and white, but it was really to emphasize we need to have access to lots of data. I just want to mention that when we talk about data, there are some areas where we still need to pay attention, that there are some limitations on how we can make this data access to the research community. Well, some of them is just scale. Not everybody has access to big computer, big processing, so that they can compute the data and they can do analysis on the data. So scale is an important one. Privacy. There are issues with user privacy. Some of you, if you work in the health domain, you know that data related to patients, well, it's sensitive. We cannot just make it available out there. I work in the context of the web. In the context of web search, another example would be search logs. Those searches, those queries that people enter in the search box, they also have some sensitivity attached to them, and I'll give an example later. And another one, of course, when that data is not out there, made publicly available, but belongs in industries, could be in in pharmaceutical industries, or for instance, industries like for Microsoft, I was just talking about search logs. There are some business sensitivity, like in the context of search logs. Well, people pay, like the big company, the information industries who design those search engines, they don't want to put their search engine out there because this is the way that they make money. So for profit organizations, same thing for pharmaceutical industries, right? So one of the topics I've been addressing when interacting with the research academia was how can we make this large-scale, real-world data access in a way where researchers can do research, right? But also making sure that we take care of the privacy, the scalability, and the business sensitivity. So and as I built those programs, there has been an evolution going from data release, like building some data set to provide to the community, adding some data compute, and now moving toward data services. And I'm really interested in the feedback from this community in terms of how easy or difficult it is to do research when now we don't have access to the raw data and I have it now on my computer, but now I use a data service to start doing research. So first of all, just why an industry like Microsoft would like to engage with the community in the context of data. Well, we really believe when we talk about data-driven research that to enable further and next-generation innovations, we really need to engage with the research community, right? That's where most of the brains are there, right? It doesn't scale just to keep everything in some labs. By doing that, we think there are at least 3 promises here. One is innovation. It's just to help come up with new research directions that we hadn't foreseen, right? It's also science, because in some cases, if the data is only accessible to the researchers in industry and not outside, how can people repeat, right, the science? So, and confirm or not what has been discovered. So it's really about also enabling science. And last but not least, it's also about training. And specifically when we talk about large scale, not all universities have access to large-scale computing, for instance, right? So how can we help with that too? And there are, for instance, there are some other talks, and I encourage you to look at them later online or read some papers about that going on now or later in the day about providing data compute. And here I put it again, let's remember that we still have to make sure we take into account those business sensitivities, those privacy issues, and make sure that when we engage with anyone outside of the industry and those data sets have sensitivity, that the privacy of users are protected. So here's the example I mentioned earlier in the context of web search. Search queries could have some sensitivity. Here's an example of this person whose identity was revealed based on the history of her search log. So there was an industry who it wasn't Microsoft, who put outside like 20 million queries, which was very interesting for the research community. However, like some data snoopers, just going through the history of the searches that this person had made, they were able to identify a person. So this is a real issue, right? It's not just saying we want to protect privacy. Some data snoopers can identify people, even in things like search queries. Here we're not talking about, like having a table with social security numbers, etc. It's just based on the history of search queries. So this is a sensitive topic. So what we did, like a few years ago, we provided access under licensing agreement and to a small number of universities some search logs that had been anonymized, where we got rid of any identification. And so we had this program, and a year later, we had like 10 awardees, and a year later, people came to talk about the research, what they had been able to do, and the things they were able actually to do with this type of data, which is very difficult to have access to. And one of the questions I asked them was the quest for asset. I said, when you present, also tell us what was good, what was so good about the data you received, and what would you like. And here, if you look at, so we're talking about 15 million search queries, some click-through information, and that was, of course, in the context of web search. And so when people came at the summit, they said, we need more data. 15 million queries is really small. Come on, you're a big company, you have lots of data. Can we have access to more data? And so you talk about doing large-scale research, so give us large-scale data sets. Another ask was, the data set you gave us was not very useful to follow a user. So, that's by design. This one, there is no way we will be able to do it. So there are things we were able to take into account from what came back from that feedback, and other things we can't. So we did take into account more data. And we ran another program like a year later, or so, a year or two, where we provided more data. So actually we went to, I think, 100 million queries under the same conditions with the licensing agreement, anonymizing the queries, and a small percentage. So it was, this time was, I think, like 20 awardees we had. And then what came back, which was really interesting to me, was, some people said, it's too much data. We cannot process it, right? And so some people said, actually, what would be really interesting is to have access to the data, and not just the raw data. We don't need, actually, the raw data for what we want to do. Some people need it, right? And some others didn't. But what struck me was like, well, now we need really data access, and we need compute power. So that goes back to, in some universities, where there is not compute power. So we did take that into account to a new program where now we moved from data release to adding data compute and moving toward data services. And that's where we are now with respect to data. So we've been running a program for a year or more now, a year and a half, where we built a service which is called the Web Ngram service, and you can access it on the link there. And where the goal, the vision, is to provide access to petabytes of real-world data. So what we did, we took the big index, which is this big, so Bing, the search engine from Microsoft, and we took the Bing index there and built some language models. And now we provide access to not the whole Bing index. We didn't, first it's kind of big, right? So it's difficult to just say, okay, we're going to ship the Bing index. And and we cannot just give it away anyway. But I mean, so we did build this service where then people can start developing applications or doing research from that. These are some of the technologies where web ngrams are used, some of the applications, so search, machine translation, speech learning. So something we did this graph here, so on the bottom here, we're talking about the different grams, from unigrams to 5 grams. And then this the number of queries, this was based on the subset, obviously, of the big index. But what I want to emphasize is that here, what you see in blue here is the language model of the queries of the user. So that means that a user puts a query out there to a search engine, and then if we want to retrieve document, they need to match somehow to be the closest possible to that line here, right? And so here, just looking at those boxes here, you can see that, in fact, the anchor and the title of a web document are much closer to the query of a user than the body of a document. Whereas usually we use the body in search engines, right? So as part of this program, we are making access to the research community, access not only to the document body, but also to the title and anchor text, so that people can do interesting research in search. What I put in red here is like what's different from other programs which are out there using Web Ngram. An interesting aspect too is like we are providing the ngrams for all the documents in the English market only, not yet Spanish, maybe one day if we can. But in the English US market, everything, the whole data, there is no cutoff. The other one, which is different from other offerings, is that we are hosting the service. And then we are doing periodical updates. Like right now we have, in fact, 3 snapshots of the web ngrams built on the web, which are accessible to any one of you. So let me give you some example of how we can use the data, this data service. So this is an application which was built using the Twitters, and if people tweet, I don't see too many people using tweets here right now, which is good. I'm not doing email either, which is perfect. And so here what it is, if you recognize, these are hashtags, right? Like when they do some conversations, you have an hashtags, and then you can follow someone in some conversations. So this application, what the person did was to use the Web Ngram and then use the API from Twitter, where you can get, I think it's weekly, like the most trendy tweets, right? And then, so that's not recent, that's a few weeks ago, I think like maybe a month ago. And from that, saying, well, can we do some word breaking, like very easy word breaking by using the Web Ngram? And so here's an example, if you see over there. Okay, let me put the cursor here. So yeah, oops, let me go back, sorry. So this one, if you look at the hashtag is all concatenated, right? All the characters are concatenated. And by using the Web Ngram, well, if you can see, the first one is pretty good. And this is really, really, I was going to say, a brain-dead word breaker, as it were. When I first met, well, the first result, so what it gives is like the probability. So the first one is the best. It's probably what the word breaking should be for this hashtag when I first met. Here are some other examples, now playing. Yeah, that got a pretty good result. Enough is enough. You can see the first one is also pretty good there. This one, I really like it because the first time I saw it, I had no clue what it meant. And it's just when I saw actually the way it was broken into pieces that I could read it, wait for you, okay? And that, I come from natural language processing background, but it will be very difficult, I think, to get that. Whereas here it's just the sheer power of data, right? Of course, I had to use some French, and I can tell you that it's parsing correctly. And I even ventured in Spanish, Buenos dias, and I believe it's also correct. So this is just an example of an application using the web ngram and then doing, for instance, here, word breaking. That's another one. This is somebody from the Rensselaer Polytechnic Institute who also used the web ngram to see if he could make sense of the title from data.gov. So the title in data.gov, the data set he was using, are extremely large, long titles. And so if you look on the left-hand side, if you use just a single, and he wanted to use some tag clouds to do that. On the left-hand side, this is just using one word at a time. And so this is the typical cloud that we know. And you can see that data is emphasized, inventory, release date, but there is not a lot of context there. On the left-hand side, by using the web ngram, he was able to start doing a little bit more context here, give more context, right? So we see critical habitat up there. This one is like really super long, like toxic release inventory data. What is interesting about what he did, actually, is not so much the multi-tag cloud per se, because some other people have developed this idea of multi-tag cloud, but what was really interesting is the agility. He was able to build that in a very short period of time, in a few hours. And so that's how can we enable this type of agile experimentation by providing access to real-world large-scale data. So that's a very good example. Here are some other examples. Another example, which is query segmentation. So these are examples which exemplified actually if we use the web ngram on the content, on the body of a document or of a title of anchor, you get different segmentations. And what is interesting here too is that this is just, again, just the sheer power of data, giving you some probability about that might, for instance, if we look at both body, all of them actually, body, title, or anchor, Mike Seawick is probably an entity. Of course, the web ngram is not smart enough to know what type of entity, but it's just saying that's a grouping, right? So, and then lawyer and Michigan, so the title didn't miss it, but the body and the anchor text, they're also say, these are probably separate groupings. So what I just said, to summarize a little bit here, is just about the sheer power of data. In the example of the word breaking, as you saw, I used some example like French, Spanish. We played with the colleagues, I'm working on that. We played with other languages. We are multilingual. So we played with German, with, actually we also have a lot of the colleagues here are Chinese, so we try some Chinese. And of course, this is anecdotal at this point. We have not run any evaluation, but it was really interesting to see that even just on the EN-US market, we were able to get those very good results based on just the EN-US market. And so it looks like the web is really cross-lingual. And so in a sense, we're kind of like, well, maybe when we talk about language identification, we saw more variations, not so much between natural languages, but more in terms of how people write in the body of a document versus the title of a document. So we're kind of playing with the idea, like, well, maybe language identification is at another level. So this is the type of research that if somebody was really interested, could pursue, right? Is it true, actually? So for people who want, I won't spend too much time here, but for people who want to learn more, there was a workshop with some papers who talk about actually the research which was done with the web ngram, and not just the applications there. Here is another example of here. I want to start going into on the semantic space. But kind of how can we bridge the gap, right? When I was talking at the beginning, I said we want to go from the paradigm from data, information, knowledge, and eventually intelligence. But of course, when we talk, this just comes naturally, right? It's not this big break, or all of a sudden we just are exchanging strings and we don't know what we're talking about. Well, this happens to me when somebody speaks Chinese to me, actually. So this is kind of the data level. But otherwise, most of the time, when we communicate, we are in the information and knowledge level, right? And so from a processing point of view, can we also, do we need in a way which is not just, well, we stop at the data, or now if I do research on knowledge, is very different type of research. So that's here an example of what we're trying to do. So we started with the web n-gram. So here, that's the query segmentation up there with the Chateau Montelena in Napa. And just try to apply it like to a blog. That's a wine blog there. And then the idea is that, well, with the web n-gram, we can identify some grouping, right? So in that case, I have highlighted Chateau Montelena. But of course, as I mentioned earlier, the web n-gram, so just those language models don't tell us exactly what is Chateau Montelena, what type of entity is that. So now if I have access to other type of sources, like here, for instance, I'm using Wikipedia, and with, sorry, I think it's a bit fuzzy here, but Wikipedia with here these info boxes, right, which are taking the Wikipedia, which actually gives like some structured information on this entry. Well, now we can start having a bit more information about what Chateau Montelena is, right? And so I don't know if you, actually I can hardly read myself here, but it gives the location, it gives when it was founded, and so it gives some different types of attributes. And then if you have access to those attributes, then maybe you can bring back to the user some information, which is what you see there on the right-hand side corner of the blog, right? Like, for instance, where there was a movie, Bottle Shock, or here's how the castle looks, right? So how can we bridge those gaps, like starting from something which is really sheer power of data, and now I bring some knowledge when I know, like here I'm just in the context of, let's say, wine. Okay, before I move to a bit more of the knowledge world, just want to do a plug here for a challenge we're doing where you can use the web n-gram, so it's not a very complete artificial plug here. And the reason I'm bringing it up is because it finishes next week. So if some people were interested, some of your students, so we are running a contest, the Speller Challenge, which is about developing the best speller out there, right? I showed you a very crude one with, well, it's not a speller, but I mean the word breaking, some example of how you can play with the characters. So here is like, you can do without web n-grams, but you could also use it. And so as I mentioned, so the end date is May 27. We have automatic evaluation of the spellers, and if you have students, we have 5 prizes to win. So you can go to spellerchallenge.com to find more information. Something which may be interesting to your student, to yourself, as part of the web n-gram, we are also making access a data set which is based on queries, real-world queries, bid for track. So these are not Microsoft queries. These are queries which have been put together by TREC, which is the text retrieval conference, which has been run for decades now. And so what we've done is like using those search queries and generate misspelling, so that people can have kind of a sense of queries and what could be. So we've done kind of the opposite, right? But just so that people can have access to some real-world queries. So that could be an interesting resources. So to summarize this part, I did mention that we went from data release to data services. Why? What we've found is that it allows to handle much bigger data sets. It allows to provide abstractions on the data, right? I was just talking about the language models, the web n-gram. It also allows us to provide data compute capabilities. It allows for agile experimentation also. The agile experimentation, I gave the example of the cloud, the multi-dark cloud. So some questions for you that at the end here, if we have time, we started late, or during these 2 days, I would love to hear from you about how we can better engage in the context of driving data-driven research. How using a cloud-based data service approach helps or not, does change research. And what else can we do in industries to help democratize large-scale data-driven research, right? First thing is access to data compute. But what type of resources are really interesting? And let me get towards knowledge. As you can see, towards, so we're not going to reach it here today. But we're on the path. So the world has become more connected, much more connected, as we know. Data sets have been more connected. So if we look at people are connected in different ways, right, today. Lots of devices, sensors. Here's the community using those type of devices, having access to them. And there is also this effort about data which is out there starting to link it, right? So this is linked data. And I have, I believe, a newer version. Well, it's still actually 2009, but this one I think may have been 2007. Sorry? Okay. Thanks. And so this one, that's a snapshot, which is still old, but is growing and growing, where people are linking their data using some protocols. And so if you can see here on the, here I just highlighted a few of them, like, so cross-domain in the middle, and it's all centered around kind of DPP. If you see, like, there is, everything seems to be going to these info boxes from Wikipedia, the DPpedia over there. And so, and per domain, you can see, so the colors reflect those different domains, right? So there is more and more data which is being linked. However, we still don't know exactly what is there, right? I mean, if we were able, just with those data sets which are linked, to really understand what is in there and how they relate to each other in a more meaningful way, we could have so much more information about locations, about so many things, people, etc. Right now, it's still not there, but it's a very good first step. But let's not forget that data information is dynamic. So being able to just trying to craft and tag and think that is going to stay out there forever, it's not realistic, right? There is more data coming in, there is more tags coming in. And here, just to give you an example, I was just looking at Wikipedia, and I just looked at English, which is where there are the most changes. There are 450,000 changes per day in Wikipedia. Okay, these are just changes. And of course, these are changes which may not be semantic, right? But some of them probably are also semantic. If we look at the number of words, so that's, I think, in the global, I forgot to put the reference here, but if you're interested, I can give you, there are a lot of interesting statistics. One new word created every 98 minutes. So about 14.7 words a day create daily. And that's just English, right? So obviously, there is more data coming, even just in the vocabulary, right? I'm not talking about sensor data, weather data, just in the, this is vocabulary. And some are contentions, and are they part of the vocabulary or not? For instance, Web 2.0. Is it a new word, or is it just, okay, now it's part, it's a new word. So that's the type of word we're talking here. And so, and then I wanted to go to the question of, is there such a thing as a right ontology, right? And well, first, so two things. One is that ontologies are abstractions. So ontologies and those experts are going to make decision choices every time, right? So it's not just like, probably not two ontologies are going to come up with the same thing. Most importantly, ontologies are also application dependent. And here I'll try to put this example. If I contrast an application, machine translation, with robotics, for instance, if I am interested in doing machine translation with eat, the word eat, right, and in Spanish comer, well, if I do, and I'm not using just a statistical-based approach, but I want to actually craft an ontology to say, okay, here's how I go from eat to comer. So I would have something like an ingest concept, right? In other languages, I may have to add, like if there are different, if there is a different way to eat when you eat solid versus eat liquids, well, in English, of course, it's drink. But let's say in a language that it could be eat with liquid instead of, right, drink. So maybe you would have to add an attribute to say, actually, it depends what you ingest, if it's liquid or not. You may have different ways. And actually, in this case, maybe ingest is food, right? And that's pretty much what you need. We don't need to know how you put the food in your mouth, how it goes, and how it affects your stomach. We don't need all that information. If we now talk about robotics, it's a completely different field here. Here we're talking about task planning, right? This is not just about a concept. An ingest concept wouldn't get us very far in the context of robotics to have a robot go and eat something, right? We need to understand the environment, the context of the robot. We need to understand the initial task, where we're trying to go, and how we get there. So we're talking about complex actions. So just to say that, then, is there a right ontology? Well, probably not. And is it? There are several out there, and there should be several out there. So let's look at two examples here, which are under development. And the idea here is, can we get, I started the presentation with talking about Largescale. And here's the same idea. We want to see if we can bring this knowledge at scale, at web scale. And so to do that, we cannot start from crafting an ontology or something like that. We really want to start with information which is out there, and how can this be translated into knowledge eventually. So some of them, here's an example first of some ontology-based data, Yago and IMDb, which are actually part of the link data that I showed earlier. And see first, well, can we just merge those automatically? There are already plenty of ontologies out there. So the first step, how can we merge them automatically and with very, very good results? So here's an example of trying to do it by using probabilistic modeling. So the example of Yago here, as you can see, there are 400 million, that stands for million facts, 108 relations. The IMDb, if you are not too familiar with it, so this is a database where there are some movies. And there are 23 million facts and 10 relations. So of course you can see just with these two examples the challenges you have to face. First, there are differences in information coverage, right? If you have 400 million facts versus 23 million facts, well, there is a chance that you are not covering exactly the same thing. There are mismatches at the text level. Here's an example in Yago, or the other one. It's Kim Novak with an underscore, whereas in the other one is Novak, Kim, right? These two things are the same. There are concept mismatches, as it were, so mismatch, but differences to be sure. In one, and they mean the same, right? One was created on date versus has production year. Actually, they use different terms here for the concepts there, right? The other one was at the instance level. And there is also granularity differences. For instance, in the context of IMDb, there are multiple entities per episode of a TV series, whereas for Yago, there is just one, right? So there are all these challenges. So doing an automatic match, only 20% of the entities were matched exactly in the first approximation. And so the work which is going on at the University of Cambridge with Professor Garamani and his team is that what can we do more of this probabilistic modeling so that we can end up matching like 80, 90% of those ontologies. And then linked data would become something that now it's not just linked data. Now we would be talking about linked information. That's one example. Because I need to wrap up soon, I'm going to talk about another example, Largescale, which is being developed by our colleague at MSRA, which is ProBass. ProBass, just to give you an example here, just let's look at the three boxes here. It has 2.7 million concepts. Now we're talking as far as scale, right? If we compare to FreeBase, 2,000 concepts, and by the way, those million of concepts were harnessed automatically, right? So again, because it would be very difficult to do that manually. FreeBase, 2,000 concepts, community effort. And Psych for some of you who may know who's been actually over 2 decades effort, there are 120,000 concepts. Of course, the granularities are absolutely not the same here, right? If you look at Psych, what is being described in Psych and what is being described in ProBass. But just to give you a sense of the effort being used that you need to get where. And what we want is to be able to build these really large-scale knowledge bases. So another aspect which is interesting in ProBass, and also the other effort I was talking about, which is developed at the University of Cambridge, by developing these probabilistic knowledge bases, is like to take into account uncertainty right there. So if we look at the difference between ProBass and FreeBase, so on the right-hand side, knowledge is kind of, thank you, it's kind of black and white. It's not exactly like that, but pretty much. Whereas what constitutes knowledge in the case of ProBass is a probability, right? In some cases could be, so it's going to change. It's much more dynamic. In the context of FreeBase, you have to clean up everything. It's very difficult to start cleaning up when we talk large scale, right? So we can live with data which has not been cleaned. And actually, it's useful. So let me give you like a couple of examples of how this has been used. Well, first of all, before I do that, here are a couple of examples of the concept apple, right? If you look at the word apple, just by itself, looking at the data, at the first graph out there, it's really talking like, and that's in the context of the web, this is computer. If people look for Apple on the web, they look for the computer. They look for Apple, the company. They don't look for Apple, the fruit. Now, if we start adding a pair, apple and pear, well, now we change. We're talking about, I can say like food, fruit juice, juice, and that's all done dynamically, okay? And so that's a very interesting way of now being able to develop applications. So some of which I'll give just a couple of them. One is to do, and these applications have been developed by our colleagues at MSRA. So one of them here is doing concept search. So you're looking for a company, and here are the grouping, and this is visualization. So now it gives you some grouping about what is inside the company, for instance, like company organization, and on the top left hand side there, these are instances like Microsoft and other Nokia and other companies. Another one which is interesting is to understand tables. So for instance, there are a lot of tables on the web out there, right? If I look at American politicians' birthday, so it's able to understand that, well, we're looking for American politicians, and we're just looking actually, and looking for the birthday, and here what it would retrieve, right? And I have another example, which is films budget. So that the query is like films budget, and here it retrieves a table where it understands that we are interested on the budget, the one which is highlighted there, of different movies there. And as you can see, it gives some other information too. To summarize, so I talked about data going from data release to data services to drive innovation in the context of data-driven research. And we've seen some examples, and we are still working on it. And so some examples where indeed the sheer power of data is really helping to develop large-scale applications. The other part is how do we go from data and information to knowledge? It's a knowledge world. There are a lot of, we've seen linked data. It's all this data which is linked, and if we can actually understand what is in there, we could get to a knowledge world. Something like ProBass, which is harvesting the web, also gives us a lot of information about our lives, in fact, right? How many people go on the web, like web pages, home pages, blogs, you name it, okay? So how to go from data services to knowledge services. And then the question that I asked before, but now I will extend to include knowledge. So how can we better engage with you to drive this type of research, semantic computing research, and doing that providing access to services on data, on knowledge, is it something which is interesting for this community? And I'll stop there. Thank you. So I don't know if I have time for questions. Or...